Our next topic is fraction to decimal. Converting fraction to decimal. Divide the denominator, the bottom part, into the numerator, the top part. 1/4, for example, 1 is the numerator, 4 is the denominator, or the same as 1 divided by 4 equals 0.25. Another example, 1/2 equals 0.25, 3/4 equals 0.75. Our next topic is decimal to fraction. Converting decimal to fraction. Example, 0.5. 50 divided by 100 equals 1/2. Example, what is the equivalent unit from decimal to fraction? 0.25. A, 1/4. B, 1/2. C, 3/4. Answer A, 1/4. Our next topic is percentage. Percentage is a number or ratio that can express as fraction of 100. If we have to calculate percent of a number, divide the number by a whole and multiply by 100. Example number 1. The passing exam to be accepted as apprentice electrician is 70%. A, 0.07. B, 0.70. C, 70. D, 700. Answer B, 0.70. Example number 2. The overcurrent protection device is 80% of the device rating. And if the protective device is 40, what is the device maximum load permitted? Answer A, 32 amps. Solution, convert the 80% to decimal, 0.80, then multiply the 0.80 by 40 amps. The answer is 32 amps. If this is your first time here, please don't forget to subscribe and hit that notification bell so that every time I will upload a new video, you will be notified. And also, check my other video like interview question and answer, hydraulic pneumatic, FANUC robotics, motor controls, and many more. Our next topic is parentheses. Parentheses are a group of steps in a correct order. Example, the sum of 5 and 15 added to the product of 3 and 4. Example here, open and close parentheses, 5 plus 15, plus open and close parentheses, 3 times 4. 5 plus 15 equals 20, plus 3 times 4 equals 12. The answer is 32. Our next topic is reciprocal. The reciprocal is simply 1 over a number. To get the reciprocal of a number, we divide 1 by the number. Example, 1 divided by 1.25. 1 is the reciprocal. Example, what is the reciprocal of 125%? A, 100%. B, 75%. C, 80%. D, 125%. Answer C, 80%. Solution, convert 125% to decimal equals 1.25. Then 1 divided by 1.25 equals 0.8 or 80%. Our next topic is kilo, mega, centimeter, and millimeter. The letter K mostly used in electrical and electronics term, and the prefix of kilo is 1000. We have here sample of symbol, prefix, and multiplication factor. Example E, exa, 10 to the 18th power. P, peta, 10 to the 15th power. T, tera, 10 to the 12th power. G, giga, 10 to the 9th power. M, mega, 10 to the 6th power. K, kilo, 10 to the 3rd power. H, hecto, 10 to the 2nd power. Da, deca, 10 to the 1st power. D, dc, 10 to the negative 1 power. C, centi, 10 to the negative 2 power. M, milli, 10 to the negative 3 power. Micro, 10 to the negative 6 power. Nano, 10 to the negative 9 power, pico, 10 to the negative 12 power, femto, 10 to the negative 15 power, atto, 10 to the negative 18 power. Example, what is the wattage value of 12 kilowatt rated electric range? A. 12,000 watts, B. 10,000 watts, C. 9,000 watts, D. 1,200 watts. Answer A. 12,000 watts. Solution, 1 kilowatt equals 1,000 watts. 12 kilowatt times 1,000 watts equals 12 kilowatt. A heater has a wattage of 800 watts. What is the equivalent kilowatt? A. 800 kilowatt, B. 80 kilowatt, C. 0.80 kilowatt, D. 8,000 kilowatt. Answer C. 0.80 kilowatt. Solution, kilowatt equals watt divided by 1,000. Kilowatt equals 800 watts divided by 1,000 equals 0.80 kilowatt. Our next topic is area and volume. A volume in cubic inches or millimeter can be determined by multiplying the length, width, and depth by the enclosure. We have here example of utility box. The length is 4 inches, the width is 4 inches, and the depth is 1.5 inches. For the formula of volume, V equals length times width times height, V equals volume, L equals length, W equals width, H equals height. Example number 1. What is the volume of a junction box 4 by 4 by 1.5 or 1 1/2? A. 20 cubic inches, B. 24 cubic inches, C. 26 cubic inches, D. 30 cubic inches. Solution for 1 1/2 equals 1.5 equals 4 by 4 by 1.5 equals 24 cubic inches. Our next topic is area of circle. The round part of a circle is the circumference, and the diameter is 6 centimeters, and this is the radius. The formula is area equals 5 times r squared. Our next example, diameter is given. Radius equals 6 centimeters divided by 2. Radius equals 3 centimeters. By using the formula, A equals 5r squared. Area equals 5 times 3 centimeters squared. Area equals 28.3 centimeters squared. Our next example is area of a semicircle. The diameter is 10 centimeters divided by 2 equals 5 centimeters. By using the formula, A equals 5r squared divided by 2. Area equals 5 times 5 centimeters squared divided by 2. Area equals 39.3 centimeters squared. Please look here for your additional reference. Our next topic is square root. Square root is a number which produces a specified quantity when multiplied by itself. 7 is a square root of 49. For example, the square root of 25 are 5. Example number 1. 18,000 watts divided by 208 volts times square root of 3 is equal to. Answer C. 50 amperes. Solution. The decimal value of square root of 3 is equals to 1.73. Divide 18,000 watts by 208 volts times 1.73 equals 50 amperes. Example number 2. The phase voltage 208 volts divided by square root of 3 is equal to A. 120 volts, B. 208 volts, C. 360 volts, D. 460 volts. Answer A. 120 volts. Solution. The value of square root of 3 is 1.73. 208 volts divided by 1.73 equals 120 volts. Our next topic is basic formula. Review yourself for common formula and units. Our next topic is series circuit. In series circuit, the current that flows through each of the components is the same, and the voltage across the circuit is the sum of individual voltage drop across each component. Sample problem. A 3 lamps connected in series with a circuit having a resistance of 100, 300, and 50 ohms. Plug in a 12 volts power supply. What is the current? The formula of series circuit, RT equals R1 plus R2 plus R3, and so on. And now we're going to substitute the value of its resistor or bulb. R1 is equals to 100 ohms, R2 is equals to 300, and R3 is equals to 50. We are going to sum it up. The answer is 450 ohms. And now to solve for current, we use Ohm's law triangle. I equals V over R. Our voltage is 12 volts and the total resistance is 450 ohms. Now the current is 0.027 amps. Our next topic is parallel circuit. And parallel circuit is one that has two or more paths of electricity to flow and the load are parallel each other. And we have a sample problem here for parallel circuit. A parallel circuit having a resistance of 20, 30, and 40 ohms connected to a 12 volts power supply. What is the current? The formula of parallel and resistance is 1 over R total equals 1 over R1 plus 1 over R2 and so on. And then we are going to substitute the value of resistance. 1 over RT equals 1 over 20 plus 1 over 30 plus 1 over 40. And the answer is 1.08. And then we're going to cross multiply to simplify. Therefore, RT equals 1 over 1.08. And the answer is 9.26 ohms. To solve the current, we use Ohm's law triangle. I equals V over R. Our voltage is 12 volts. Our total resistance in parallel is 9.26 ohm. And the answer is 1.3 amperes. This is the applications of the formula that we discussed previously. Example, a 3.5 kilowatt motor with a voltage of 230 volts. What is the current? Power formula. P is equals voltage times current. I is equals P over V. 3,500 because we know that 1 kilowatt is 1,000 watts. So 3,500 watts over 230 volts. So the answer is 15 amperes. Next question. A 5 kilowatt motor, how many horsepower? We know that 1 kilowatt is 1,000 watts. In order to find horsepower, 5,000 divided by 746, the result is 6.7 horsepower. Thank you for watching and see you on the next video. If you like this video, please like, share, and subscribe. Have a good one. Our topic for today is motor branch circuit calculation for single phase and short circuit ground fault protections for our feeder. I will take a look also at table 430, table 31015, and table 240 for full load current for inverse time breaker. This is the short circuit and ground fault protection to the contactor and overload relay, and down to the single phase 5 horsepower 230 volts motor. When we are going to size the branch circuit and feeders conductors, we're gonna use the FLC or full load current. That is in table 430, 50. Let's talk about the steps that covers in sizing branch circuit. The first thing we're gonna do, find the full load current from the table 430-248 for single phase, and for 3-phase 430-50. It says 5 horsepower, 230 volts, 28 amperes. Because it is continuous during motor, let's assume unless it states something else, like elevator that is intermittent duty, we're gonna take 125% for sizing this front circuit conductor as per neck. 43022A that tell us for this continuous duty motor, 1.25 times 28 amperes equals 35 amperes. The usual small conductor for residential and commercial, like 14 gauge for 15 amperes and 12 gauge for 15 amperes, that is for general application but does not apply here. Third, find the conductor at table 31015B 16. It says 35 amperes. Copper conductor, remember that the default motor terminal ratings for is 75 degrees C as per National Electrical Code table 110410C. It is a thin gauge. For our short circuit and ground pole circuit protections, 28 amperes times 2.50 equals 70 amperes as per table 240.6-A. The 2.5 or 250% is the percentage of full load current for inverse time breaker. Next, how to convert kilowatt to horsepower. Our example here is 15 kilowatt. Kilowatt is the unit of electric power. And horsepower is a unit of power equal to 550 foot-pounds per second or 745.7 watts. Given 1 horsepower is equals 746 watts, 1 kilowatt is equals 1000 joules per seconds. Answer: 15,000 watts times 1 horsepower over 746 watts. We're going to cancel the watts. So it should be 15,000 divided by 746. 15,000 divided by 746 equals 20 horsepower. Welcome to Automation Academy TV. Our tutorial for today is what is the difference between a relay and a contactor. Relay and contactor same the same function by switching a circuit. if you see from the application point of view, you see a magnetic contactors placed inside an electrical cabinet, while relay used in low voltage applications such as alarms and pilot lights, etc. Both shares the same functions, electromagnetic switching, and operate under the same principle. Let's recall first magnetic induction, because without this theory, we don't have a relay, magnetic contactors, motors, generators, transformers. This principle still used most of the electrical utility today. Electromagnetic induction was discovered independently by Michael Faraday in 1831 and Joseph Henry in 1832. Faraday was the first to publish the results of his experiments in August 29, 1831. Michael Faraday was an English physicist who gave one of the most basic law of electromagnetism called Faraday's law of electromagnetic induction, while Joseph Henry was an American scientist. Relay can be used to control several circuits by just one signal. A relay contact having one or more poles, each contact energizes other circuit or stop another circuit. Protective relays can prevent equipment damage by detecting electrical faults like overcurrent, undercurrent, overloads, and reverse current. Additionally, relays are also wide use in heating equipment, pilot lights, and audible alarms. A magnetic contactor have three main contacts, line 1, line 2, line 3, or 1, 3, 5, and T1, T2, T3, or 2, 4, and 6. Have many auxiliary contacts like normally open and normally closed, used for interlocking and making other circuit. Power contactor is generally used in large amount of current to make and break large carrying load like 10 horsepower to 900 horsepower. High voltage AC contactor greater than 1000 volts may use vacuum or inert gas around the contacts and extinguishing electric arcs. Hello guys, good morning. Our topic for today is what is a relay and how it works. A relay is an electromagnetic switch operated usually by a small amount of current that can turn on or off a larger electric current. The heart of a relay is the electromagnet, a coil of wire that becomes a temporary magnet when electricity flows through it. This is a relay showing which pin is normally open or closed contact. In this example, the initial condition of the circuit while the switch number 1 is open, relay is not energized and the electric motor is not running. What will happen if we are going to close the number 1 switch? The current flows from 24-volt supply battery through number 1 switch through number 2 magnetic coil and energizing the magnetic relay. Once the magnetic relay energizes, the number 3 single pole double through or SPDT contact change its state from 11 to 12 through 11 to 14. And the current from number 4 power voltage 230 volts flows through close contact number 5 motor, and the motor will run and the current flows back to power supply. Now let's do our practical exercise. Guys, today I'm going to show you how to wire a relay that can control a big motor. Let's do it. From the positive of our power supply, we're going to connect it here. Positive of our power supply, going to our switch, going to coil of a relay A1. From A1, from A2 of the relay, going back to the negative of the power supply. Now let's try if this relay will plug in. It works. From the positive of our power supply, we're going to connect another supply. Going to the normally open of our relay. From another side of the normally open of the relay, going to the coil of the magnetic contactor. From A2 of our magnetic contactor coil, going back to our negative of our power supply. In this scenario guys, I didn't plug in yet the motor, but anyway, I already connected the power circuit of the motor. When I'm going to press this one should plug in. Doesn't run yet because I didn't plug in yet the power supply. Let's try. Okay, both of them is plugged in. The relay energized and the contactor energized. Once I plug in the power source of the motor should run. Now I already plugged in the motor. Let's try if it works. It works, guys. So this is a relay, how to control a big motor using contactor and power supply. Hello everyone. Today we're going to discuss about what is magnetic contactor and how it works. A contactor is an electrically controlled switch used for switching a power circuit similar to a relay, except high rating as high as 5,000 amperes. A contactor is controlled by a circuit with a much lower current and voltage like 24 volts DC and are used in application ranging from light switch to the most complex automated industrial equipment. It is used by electrical equipment that is constantly on or off with opening and closing a circuit. Contactor has two sets of auxiliary contact. NO stands for normally open and it will close when the switch is activated. NC stands for normally closed and open when the switch is activated. A magnetic coil when energized will attract the moving core of the contactor, and the voltage of the magnetic coil usually 24 volts DC, 110 volts AC, or 230 volts AC. Contactor has three main sets of contact. For supply side, line 1, line 2, line 3, or 1, 3, 5. And for the load side, going to the motor, T1, T2, T3, or 2, 4, 6. The overload relay is always part of magnetic contactor and is designed to protect the motor against prolonged overcurrent. This means if the motor is running for too long with high current, it will overheat and destroy the motor. One of the causes for this is bad bearing. Parts of overload relay: current setting. To set the current setting of the motor, you need to know the full load current times multiply it with 1.25 or 125%. Stop button, used to stop the motor. Reset button, manually reset should be done after the motor has tripped. This is the usual setup of motor control, from the bus bar going to the main disconnect. The purpose of main disconnect is to shut off the entire circuit. And for circuit breaker, designed to protect electrical circuit from short circuit and ground fault circuit interruptions. Contactor is an electrically controlled switch used for switching higher current. Overload relay designed to protect the motor from prolonged overcurrent which cause overheat and destroy the motor. And the last one is the electric motor is a machine that converts electrical energy to mechanical energy. If you like this video, please like, comments, and share. And don't forget to subscribe. Thank you for watching. Have a good one.